Good morning. My name is Ahmed Faraz. Uh, it is my TOC PPT for my DA3. My topic is application of finite automata in search engine, and we will see how finite automata is used in helping how to find substring in search engine. So let's start now. Let's start. Introduction to finite automata. Finite automata is also known as finite state machines that are mathematical models used to represent systems that change from one state to another in response to some inputs. They are widely used in computer science and engineering fields for designing and analyzing software and hardware. Any system that is at each moment in one of the finite number of discrete states and moves among these states in a predictable way in response to individual input and signals can be modeled by a finite automation. Basically, a finite automata is a machine which contains some finite number of states and with each state reacting to an input to choose the next path. So let's talk about types of finite automata. There are several types of finite automata, including the deterministic, which is and non-deterministic, which differ in their behavior when processing the inputs. Deterministic finite automata is also known as DFA and have a unique transition for each input symbol. Whereas NFA, it is also known as non-deterministic finite automata, may have multiple transitions for the same input symbols, which differs both of the DFA and NFA. DFA can be best described and understood as one machine. NFA is like multiple small machines or DFAs that are performing computational activities at the same time. All DFA are derived from NFAs only. Let's see the finite automatas for substrings that starts and end with A. So let's see the NFA here first. So at Q0 state, if we input A, it is a confusion that it can go to Q1 as well as it can go to Q2. But in the DFA, it is very deterministic that it will go to Q1 only. For a input B, it will go to Q2. So there is no confusion for a DFA, but for NFA there is a confusion. That's what make it NFA. So let's check the NFA for the input just A. It will reach the final state, and for the input A, B, 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 A, it will go from Q0 to Q2. It will repeat on Q2 only until we input B, and after we end the string with A, it will go from Q2 to Q1. Let's check about the DFA. If we start the string with B, it will directly jump from Q2 to Q0 to Q2 to a dead state. And if we start with an A, it will go to the final state. And if we input any more number of B's, it will go to Q3. But if we end the string with A, it will jump back from Q3 to Q1, which is the final state. So the DFA looks less complex. A state can have more than one path to choose for same input. So that example we can see for the Q0 state in NFA, but the DFA is more complex. A state can only have one path to choose for the given input, as we can see that here, and the trap state is needed. So the Q2 here in the DFA is the trap state. So we have seen what a finite automata is, what a DFA and NFA is. Now the point is, how is a finite automata any useful to us? Finite automata are used to recognize pattern. It takes the string of symbol as input and changes its state accordingly, as we seen in the example. When the desired symbol is found, then the transition occurs through the transition function. Finite automata are used for searching patterns. We can get our desired output for the given input just by modifying the finite automata a little bit. We can use above properties in numerous daily life problems like given below. It is highly useful to design lexical analyzers, which is used in compiler design. And automata is useful to design text editors. This is this automata is highly useful to design spell checkers, and it is also used in search engines. We will discuss more about the search engine part. So first we should know what a search engine is. A search engine is a software that is accessed on the internet to assist a user to search its query on the World Wide Web, also known as WWW. The search engine is helpful as it carries out a symmetric search on the web and displays the result that best match the user's query. The results are usually retrieved in form of a list and is also often referred as SERP, search engine result pages. These results or information may be links to web pages or mix of images, videos, research papers, news articles, and etc. many things. So let's talk about a relationship between finite automata and search engine. Pattern searching is an important problem in computer science. When we do search for a string in Notepad, Word file, or browser or database, pattern searching algorithms are used to show the search results, and it is very important. In finite automata based algorithms, we pre-process the pattern and build a 2D array that represents a finite automata. Construction of the finite automata is the main tricky part of this algorithm. Once the finite automata is built, the searching is simple. In search, we simply need to start from the first state of the automata and the first character of our text. At every step, we consider the next character of the text and look for the next state of our finite automata. And then by inputting that character, we move to a new state. If we reach the final state, then basically the search is successful. The time complexity of this process is O to the n. The above diagram represents graphical and tabular representation of the finite automata of pattern ACACAGA. So see the number of states here are 0, 1, 2, 3, 4, 5, 6, 7. The number of total states are 8. Now see, number of states in finite automata will always be m plus 1. So our length of substring is 7 and number of states are 8. The main thing to construct a finite automata is get to the next state from the current state for every possible character. So let's see the transition function table. For state 0, for state A, there is only one state. Like for input A, you can only go to state 1 from state 0. Now see if it's working for our pattern ACACAGA. So let's try. If I put A, it will go from 0th state to first state. Then if I input C, it will go from first state to second state. Now if I choose to put input A again, it will go to third state again. But contrary to our substring, if I try to input again A, like the fourth letter of our input, it will go from third state to first state back because it is not our pattern. Uh, let's try if I try to input ACAG. So ACA, it's on the third state. So let's see in our table for the third state. If I input G in between, it will directly go to the zero state and it will start the ACA pattern again only because G is not in our substring. So basically the finite automata and the transition table. Now let's talk about the limitations of a finite automata. Although finite automata are very powerful tools for modeling and analyzing systems that have certain limitations. For instance, they cannot handle complex grammars or languages that require context-sensitive rules, and they may not always provide the optimal solution for certain problems. There are always better choices. Extensions of finite automata. To overcome the limitations of finite automata, several extensions have been developed, such as push-down automata, Turing machines, Petri nets. These models incorporate additional features such as tags, tapes, tokens to enable more complex computations and simulations. Now let's talk about future of finite automata. As technology continues to advance, the use of finite automata is likely to become even more widespread and sophisticated. New applications and extensions are being developed, and researchers are exploring novel ways to combine finite automata with other computational models, such as neural networks, which is used in AI and quantum computing also. So, thank you for paying attention to me. Thank you and have a nice day. Thank you very much.